Good afternoon, everyone. Thank you all for joining today's Resideo webinar session. Today we're going to be covering an overview of our hydronic zone valves and fan coils. My name is Jamie Quanbrud and I'm part of the Resideo Sales Training Team, and on behalf of the team here today, I'd like to welcome you to our training session. And before we get started with that technical presentation, I'm going to cover just a few administrative items for you. Please make sure you join us every Tuesday at 2 p.m. Central Standard Time, where we give you the opportunity to learn about our Resideo products. For a schedule of our future webinars on a variety of topics, please make sure to visit resideo.com/webinar for more information on these webinar topics. We do have our October schedule listed on that website, so make sure you navigate to either the HVAC and or the plumbing tabs on that website for more information. Additionally, we are recording these sessions on this same website. You can find underneath that webinar recordings tab to reference at a later time as well. Also, for our contractors who are joining us for today's live session and you're interested in earning one NATE continuing education credit, there are just a few things to note. If you provided your NATE ID on your registration form, we submit that information to NATE for your attendance of today's live session, and we won't need any additional information from you at this time. However, if you did not provide us with your NATE ID on that registration form for today's webinar and you would like to receive credit for attending this live session, we do ask that you email your first name, your last name, your NATE ID, and the date of the session that you attended to homes.university@resideo.com within 1 week from today's session. This information does get submitted to NATE on a weekly basis, and any requests that are sent outside of 1 week from today's live training cannot be processed. And just as a reminder, we can only process requests for NATE credits when you attend the live webinar session, and we are not able to process requests if you do watch a recorded version of this session. If you'd like more information about the NATE program, please visit their website at www.natex.org. And a quick note to everyone before we begin our technical presentation, all of our attendees are muted. However, if you do have questions during the technical presentation, and we do encourage questions, please go ahead and use that Q&A feature that is found in your Zoom webinar controls at the bottom of your screen. We are reserving the last few minutes of our time today to answer your questions. So as we go through today's technical training, if you do come across a question, go ahead and use that Q&A feature so that we can address it at the end of the session today. We're going to turn things over in the presentation to Chris Parks. He is our water sales leader for the West Coast, and we're glad to have Chris here with us today. He's going to share his knowledge of our hydronic portfolio with all of us. So Chris, we're going to hand things over to you. Thanks so much for being here with us today.
Thank you, Jamie, and thank you to everybody that's in attendance. What we're going to cover today is our zone valves, our fan coil valves, and talk about the differences between them, where you use them in different applications, and just go over some valve basics in general. So before we jump into everything, I wanted to give a quick snapshot of the 3 different series of valves that we're going to be discussing today. And each one of these has a slightly different application. In my market on the Western US, the V80 series is our most common zone valves, making a lot of different configuration. And they're used primarily for radiant heating, could be baseboard, in-floor heating jobs, etc. So it's probably our most common residential and light commercial, what's commonly referred to as a zone valve. Simple on-off operation, the power heads can be removed, and there is some limitations which we'll talk about. We also have our VU series, which are used more commonly in fan coil valves or tight spaces. They can handle higher static pressures, but are still an on-off style valve. And then we have our VC series valve, which are very different from the first two that I just mentioned. These not only can do on-off, but they can also do equal percentage. They can do linear flow, modulating. You've got a much higher close-off pressure, plus these can be utilized with external controls for mixing. So before we jump into any of the technical pieces pertaining to individual valves, I wanted to go over just some valve terminology and some a basic overview of some of the things that are unique, I should say consistent across virtually all the configurations that we have. So before we talk about the valves, we've got the configurations that I wanted to talk about. And in the United States, for radiant heating applications, people typically order a normally closed valve. What that means is that the port A is closed. It's closed via a spring. So when power is not at the valve, there's a spring that holds it in the closed position. It's operated with a standard thermostat, turns it on and off, and really only takes 2 wires to work. And I'll go more into the wiring a little later in this presentation. In Canada, we see a little bit more, well, I should say in certain provinces in Canada, we see more normally open valves. There's some advantages to that, mainly in the fact that if the valve does fail, the spring forces it open. So if you're in an extremely cold climates, you can actually have the valve, if it fails, bring it back to the open position. So if you have a pump on or something else, it will still deliver flow through the zone. It gets a little bit more involved with the thermostat because you basically have to operate it in reverse, but still a simplistic operating valve. 2 wires, it takes 24 volts or 120 to open or close it. And then the other terminology that's thrown around, depending on if it's residential or commercial, in residential, light commercial, we usually see normally open or normally closed. Whereas in the commercial world, you'll see fail open or fail close. They mean exactly the same thing. So I get that question a decent amount. The one that's a little unique is the fail in place. So there are no springs in a fail in place valve. What happens is when you take power away from that valve, it's going to remain in whatever position it was left in. So you essentially have to have voltage to open and close that valve. We'll talk about these primarily on the VC series valves, but it can be operated either with our Series 20 valve or a standard on-off, depending on the type of actuator you use. The unique piece to that, again, because there's no spring, it takes 3 wires at a minimum. So what that means is instead of the spring returns, like the normally open or normally closed, that you give it 24 volts and then have the spring take it back. With this one, again, you have to have electricity to power it open or power it closed. When we get into the positioning and essentially the way that they operate, the one thing I do want to mention is when you're looking at a valve and you talk about which port is closed, we always, at least with our product offering, we always stop the A port. So if the valve is closed, it's the A port that is closed. All of our valves are stamped with an A and a B, and in the 3-way valves are actually stamped with an AB. So in a 2-way configuration, that really doesn't matter too much, because if it doesn't matter if the A port or the B port is closed, if either one of them is closed, you're not going to get flow through. Where that does come into play much more is if the A port is closed on a diverting valve. So if you look at a 3-way valve in a diverting application, and I'll talk about the differences between diverting and mixing, but typically in a diverting application, you take water into AB, and then it's going to exit either through A or through B, depending on if the valve is open or closed. So in this example, if port A is closed, let's say that 3-way valve is closed, the flow will come in through AB and exit through B. When you give it 24 volts, it's going to flop the positioning of that valve. Now your flow will transfer from AB to A. So you're basically going to divert the water either through B or A, depending on if you energize the actuator. Now, when you get into our VC series valve, we do have the ability to do mixing. So what I'm going to do is keep expanding on these 3-way valve configurations and terminologies. So if you look at just the basic on-off, meaning the valve is going to open or the valve is going to close and that's it, we call that a changeover valve. So in a mixing operation, you're going to go backwards from the way I just showed it. So you're either going to come in through A and take it to AB, or in through B and take it to AB. So in other words, you're having 2 inputs and 1 output. In a diverting operation, it's the previous slide I was showing you. So you're going to divert flow one direction or another. Now, where our VC series valve becomes unique with these is you can operate it in a control configuration, meaning you can actually vary the voltage which is going to open that valve proportionally. So if you look at it from a mixing standpoint, which is predominantly the methodology or the predominant method that I see with these, is you can fluctuate that valve to take a mixture of water in from A, which could be hot, and B, which could be cooler, to deliver a consistent temperature coming out of it. So we usually use an external control to do that. And then same in diverting, but typically in diverting applications, I either see it all the way open or all the way closed. The next thing I want to talk about is CV ratings and close-off pressures, because this is something that I get asked a lot about. And what I've done is I've listed the two zone valves, the V80 series, that are most commonly sold in the Western US. So those two valves are the E1061 and the E1012. Those are both 3/4 inch sweat valves, but what happens is, I've tried to draw an image there to the right-hand side. We have one of them that has a high CV rating, which is commonly referred to as a full port, although it's not technically a full port. And then we have the low CV, which is a reduced port. So I tried to draw some images there to kind of help make that correlation. What that means is, if you look at a CV rating, the easiest way I have discovered to explain that is, if a CV rating is set at 3.5 CV, so I'm going to use the example of the 1012 zone valve that's up there, the V8043 E1012. It has a CV rating of 3.5. So the easiest way to explain what that means from a pressure standpoint is, if you were to take 3.5 gallons a minute through the valve that has a CV of 3.5, that will result in a loss of 1 PSI. But when we're looking at a radiant world, we typically measure our pressure loss through feet of head instead of PSI. So if you're looking at that 1 PSI of loss, that's going to come out to 2.31 feet of head. So people see the low CV, they look through the valve, they see the restriction, and they get worried that it's going to require a larger pump because you're going to have resistance through that valve. Well, what actually happens is, by adding that resistance, you're able to increase the close-off pressure with this style of valve. So what that means is, if you're looking at those two valves and you look at the 3.5 CV that we're talking about, it's going to have a close-off pressure of 20 PSI. And again, if we convert that to feet of head, that's going to be, I don't have my calculator handy, but that's going to be close to 50 feet of head. There's not a lot of circulators in the radiant world that are going to displace enough pressure to push open a valve with 50 feet of head capacity. So that's essentially what your close-off pressure means. Is if you have a circulator that can create more pressure differential than's listed, it's going to give you the capabilities of pushing the valve open. Now, it's become a little bit less of an issue with variable speed pumps, because they'll actually modulate up and down based on the pressure differential in the system. But if you're looking at fixed speed circulators, we have run into situations where people use the full port valve, so our 1061, which has an 8 PSI close-off. That 8 PSI close-off equates out to about 25 feet of head. So there are circulators in light commercial and commercial applications that can generate enough force to push those valves open. Now, the other thing I'll talk about, if we're looking at residential systems, going back to that 3.5 gallon a minute flow rate, if you're looking at your CV of 3.5 and you take 3.5 gallons a minute, that's going to be 1 PSI, which is 2.31 feet of head again. So if you look at that from a realistic application, most houses in somewhat cold climates use loading of roughly 25 BTUs per square foot. So if we utilize that general rule of thumb calculation, and you've got 25 BTUs per square foot, if you multiply that by a 1,400 square foot area, that's going to come out to 35,000 BTUs that's required for that area. And using just some of our general hydronic formulas, if we take 35,000 BTUs and calculate out the flow rate with a 20-degree delta T, which is pretty standard in the industry, that's going to give you 3.5 gallons a minute. So essentially what that valve means is at a 3.5 CV, if you give it 3.5 gallons a minute, it can handle 1,400 square feet at, using the general assumption of 25 BTUs per square foot, with only 1 PSI of loss when that valve's full open. So to reemphasize that, here's a couple different CV ratings. and it shows the difference in close-off pressures. So I'm not going to spend too much time on this chart, but it just kind of shows you the larger the CV rating is, the lower the close-off rating is going to be. Now, that also means the lower resistance you're going to have, but if we look at that 3.5 CV rating again that I keep talking about, I don't think I've designed a hydronic system in my past that had the capabilities of needing a larger pump based purely off of 2.3 feet of head that gets added to it. So me personally, I'd rather have the higher resistance, the lower CV rating to give me a valve that has less chance of getting pushed open. And I've never really seen it, you know, that small a pressure loss require a larger pump. So with that being said, I think I've covered most of the general terminology that goes into virtually any type of fan coil or zone valve. And what I want to do is kind of go through the different series that we have and talk more in detail about the applications and how they work and what they look like on the inside. So I'm going to start with our V80 and our V40 series. These are the same series valves, but what we do is we use a plug style valve with a ball seat. And I've got some images I'll show you to kind of talk about what that is. The temperature range on these is 40 to 240. So we do offer a steam version of this, and primarily these are utilized for hydronic heating only. We do have some versions that can be used for cooling, but we've got a couple different series of valves that do a little bit better for hydronic cooling. So traditionally, these series valves for hydronic heating only, these are on-off control, spring return, and your close-off pressure, like we just talked about, it varies depending on the size and the CV rating that you have. So the close-off pressure on these jump between 6.5 and 20 PSI. You've also got a size range on these from 1/2 inch to 1 inch. And we have lots of different connections and styles. So for the pipe connection, we've got sweat, we have press, threaded, we have flare, as well as inverted flare. And then on wiring connections, we do 2-wire, which is just the motor. We do a 4-wire, which is the motor and an in switch. And then we also offer a terminal strip, which is just the screw terminals, essentially. So lots of different configurations. 3/4 inch is by far the most common size. And then in the Western US, I see much more with 4 wires, but we got lots of different options. When you look at the 3 different configurations for operation, we have normally closed, we have normally open, and then again, we have those 3-way diverting valves that we had talked about. Inside of this product family, to continue on with all the different configurations, we have 2 different series of valves. So if you look at our 1000 series, that's the one that we've had probably the longest. The power head, which is, or actuator I should call it, is the silver piece on top. Those can be removed. That is your most wearable piece. So that's where your motor lies, your in switch lies, everything electronic lies inside of there. We've got the ability to take that off without ever having to service the water. And on the 1000 series, we designed the body to handle 125 PSI static pressure. So I haven't seen a residential system get anywhere close to that. And even light commercial systems, that's a pretty hefty pressure on the valve itself. We've got a fairly low current draw. The in switch is rated at 4.4 amps, so you can use light pumps through the in switch. And the ball assembly is completely serviceable. So the beauty of that is once you sweat that valve in or press it in, once you connect it, there's really no need to ever take that valve back out of the piping. The reasoning is we've got an adapter plate which can be removed and reinstalled, which is your actual moving parts inside of the valve. We do a 1-year warranty on those. And then what we've done is we've actually created another series that we call Series 5000. It's a little bit different. Same principle, ball style design, but it actually has a push top on it. So the actuator has a little push button that allows you to remove it instead of screwing it down. The static pressure on this is 300 PSI. So much higher pressure rating. It also draws a little bit less electricity. So 7.2 VA instead of 7.7. The ball assembly on this is also replaceable and serviceable. So again, once this one goes in the valve stream, there's no need to ever service it, or never a need to remove the valve body, because you can get inside of it through a retention ring instead of screws to access that adapter plate. The other thing that's pretty unique is when we came out with the 5000 series, we engineered the actuator to be retrofitted onto a 1000 series body. So if you have either the 1000 body or the 5000 body, that 5000 series actuator can go on either one. Now, if you put it on a 1000 series body, the one thing that you will lose is the capabilities to use the quick connect. So you will essentially have to use screws to attach it to the 1000 series body, but it attaches perfectly fine. The other thing that I want to notate here that I get questions on from time to time, our power heads on this series of valve are designed so that they're only going to operate when physically secured to the valve body. So if you were to grab, let's just say, a 1000 series actuator by itself and try to manually open and manually close it, it will act like the gears are stripping. That is just the design of the actuator. As soon as you bolt that down to the valve body, that goes away. So essentially that piston that comes up that the ball sits on, that's what locks all the gears together inside the actuator. So never try to actuate the power head if it's not physically screwed down or in the Series 5000 pushed down and connected, because those gear operators will not line up properly. Now, the beauty of this valve that we've had for a long time, part of the reason we've been so successful with it is because of the actual closing method inside. So we use a ball, and we've got a couple different material types, but we use a ball that actually rotates on a spindle. So what makes this unique is as it closes, that ball is actually going to spin on a spindle, closing on a different spot every single time. So when you look at the wear and the life on this, the wear is significantly better than most of our competition. And by most, it could actually be all. And what I've done is I've kind of showed the difference between our plug style valve and a flapper style, which exists. So when you look at the flapper style, it's going to open or close, and what happens is it's kind of like a toilet flapper. So it's going to close on the exact same spot every single time. So some of the problems with this is it can actually cause the valve to flap and bounce when it closes. So it can create some water hammer. Plus, again, when you look at the wear characteristics of closing on a single spot every single time versus closing on a ball that's spinning around, closing in a different spot every time, you can pretty much imagine the longevity of ours compared to our competition on these. And what we've done is we've actually, talking about the water hammer piece, we've actually gone through and done a test at one of our factories in Maasbach, Germany, where we've taken a third-party valve and closed it and then looked at the pressure change versus ours. So you can see on the left, one of our competitors bounces around quite a bit, whereas ours is a very, very smooth line. Now, I'm showing an image of our 5000 series valve there on the right-hand side. The big identifier on that, just kind of jumping back a little bit, is kind of the curved top. The 1000 series has a square top. But on our valve, since we engineered these actuators to have the ability to go on either the 1000 or the 5000 series valve, this actuator will actually help with water hammer. So in the rare cases where our 1000 series valve ends up with water hammer, you can take this power head and put it on that body. 9 times out of 10, that will eliminate the issues. If you're having water hammer with any of our valves, more than likely there's something in the system that's causing it, but throwing this actuator on that valve body will more than likely solve, well, I should say band-aid the problem. And then when you get into, I just wanted to touch real briefly on our nomenclature. There is a method to our madness on all the different part numbers. So if you go through this, I'm just going to go through a little bit quickly, but the first letter designates that it's a valve. And the reason I say V80 and V40 series is it's the same valve, but the only difference is the 80 is going to be low voltage, so typically 24 volts, whereas the 40 is going to be your high voltage equivalent. So that's going to be your 120 volt, your 240 volt, etc. The next letter, or I'm sorry, the next set of numbers designates if it's a two-way or a three-way valve. Then the letter in the middle is actually going to designate what type of configuration it's in. So is it a normally open or is it a normally closed? Does it have 2 wires or 4 wires or a terminal strip? It kind of characterizes the configuration of the valve body as well as the electrical connections. Carrying that through, the next number is going to designate the static pressure rating. So again, if it's a 1000 series, it's going to be a 1. 5000 series is a 5. That's kind of where we came up with that nomenclature there. And then the next set of numbers is going to tell us all the extra stuff on it. So what the pipe connections are, what the CV rating is, what the sizes is, those are kind of determined separately. Now, we make a lot of different repair parts for these valves. We've had them out in the industry for a long, long time. It's been a very robust valve, and there's a couple different repair parts for them. So if you're looking for different repair parts, we have motors that can be replaced by themselves. So if you're looking at the motor rating, each one of these has got a different part number on it. So we make some that are for hot water only. We make a couple that are for steam. And we do make a couple that are plated so they can handle heating or cooling. But again, most people go to a different series when we look at those. And then we also do a couple different adapter plates. Now, what I've seen a lot of people do, you got two options if you want to replace the guts of the valve. Let's say you've got really bad water quality, it's eating up parts in the valve. You can either buy an adapter plate, which is going to be that piece that sits in between the actual valve body and the actuator that sits on top. And you can get a couple of different types of balls in there. So we've got some that are Buna rubber and we have some that are EPDM. I'll show you the difference between those. But you can, what most people do on these is instead of getting the adapter plates, they'll actually just buy a new valve and walk to the job site and replace both the actuator and the motor together. When you look at the balls that we use, most commonly we use the Buna rubber. It's used in the majority of our zone valves, our V80 series zone valves. It's resistant to a lot of chemicals that are in the water. But we do offer an EPDM unit, and we identify that style of valve with a white ball. So if you're doing a steam application, one thing that you'll probably want to double check is just to make dang sure that that ball has got the little white mark on it. So it can handle high temperatures, and it can handle also oxygenated water. So we've got a couple areas of the country where some contractors installed jobs with Aquapex instead of Heatpex, not to pick on Uponor for the branding there, but if you have tubing in that does not have an oxygen barrier on it, you may want to look at getting an adapter plate that includes that style of ball because it's going to do a little bit better job of resisting any kind of wear. When we go to our VU series valve, they are very, very, very similar to our 5000 series valve we were just going over. So I'm not going to spend as much time on these. The big differentiator on this is the temperature range. So these can be used both in heating and cooling applications. The temperature on these go from 34 to 200 degrees. These are also going to be on-off, they're spring return. We do have some higher close-off pressure ratings on these, but we also don't offer it with as many connection types. So your options are either sweat or threaded, and your wiring is either going to be a 2-wire or a 4-wire. So they're very, very similar to the series that we showed before. The big difference is you buy these units separately. So whereas the V80 and the 40 series, you buy them as a pair. With this series, you're going to buy the valve body and the actuator separately. So the big thing I do want to highlight here is if you're looking at your different CV ratings, if you really want to dial the flow rate into, say, a fan coil, this is probably going to be a slightly better application because you can dial those CV ratings in much more exacting than you can on our 5000 series. The other thing that we do is these are in a slightly lower profile. So they're great for tight spots. So if you have like baseboard enclosures or other areas where there's not that much room, these do fit in a very low profile. And we also offer corrosion resistant actuators. So if you're in an area with real high humidity or other chemicals in the air, we do have corrosion resistant actuators, which make it a little bit more resilient out on some of those applications. But other than that, very, very similar to what I was just showing in the previous series as far as the way that the valve operates, that the ball inside of it works. It's basically the same style of valve. It's just separated and you've got some more options there. Now, where things do change dramatically when you're looking at our valve offering is our VC series valve. So instead of using a plug style like we do in the previous two series that I showed, we use a gate valve here. The temperature range on these is great for heating and cooling. So you've got 34 to 203 degree temperature range. And not only do these do on-off, but we also offer these in floating and modulating. Now, the big difference when it comes to wiring, these are not spring return. I've got some wiring examples I'll be showing here in just a few minutes that will walk through how you wire up all the different series of valves that I'm showing you. But these are a little bit different than what a lot of people are used to on residential and light commercial valves. We do make these in a bigger size range. So we've got 1/2 inch through 1.25 inch on the valve bodies. And then on the wiring options, we have a 3-wire or a 6-wire. So essentially it is a on-off with no end switch or on-off floating with end switches. And just kind of going through the nomenclature, I'm not going to read through everything on here, but I do want to highlight again the size range. So I do get asked a lot of times for 1.25 inch zone valves. My response to that is typically, well, what do you need for your flow rate? Because a lot of times you don't really need an 1.25 inch valve. You can size down to a 1 inch because, again, talking about the CV ratings, it's not necessarily pipe size. It's really more about the flow rate that's going through there and the resistance that you're going to have. But with this series of valves, we can get up to an 1.25 inch body. And again, 1/2 inch through 1.25 inch in sweat and threaded. Now, when you're pairing these up, because this is similar to our VU, you have to buy the bodies and the actuators separately. The actuators have got 2 different series. So depending on the series of actuator you want to use, you're going to have to match that up to the valve body correctly. And then we make linear flow, we make on-off, and then we make equal percentage as well. And the big difference is the way that the valves actually operate. So when you look at our previous 2 valves that I showed you, those are ball style plug valves. When you look at this one, it's a cartridge cage design. So every single one of these basically has a little cartridge that threads in. So instead of having that adapter plate, this takes the place of that. And we've got a couple different configurations. So we make it in 2-port or 3-port. So in other words, is it for a 2-way valve or a 3-way valve? And then we have on-off. So if you're just going to be giving it 24 volts to open or close it, or I keep saying 24 volts, could be 120 volts. Or if you need a control valve. So if you want one that's actually going to modulate, if you're going to have it sitting in between those extreme on and off areas. What's nice about, if you're looking at it from a stocking standpoint, I personally would only stock the control valves because they're essentially universal. The control valve configuration, the ones there on the bottom, and I've got an identifier, you can kind of see the way that you've got kind of a piece of plastic that's cut in there at an angle. It can still operate in an on-off configuration, but that also allows you to modulate it. So if you're going to stock any cartridges on your shelf for replacements, my opinion, the universals down there at the bottom are the way to go. And then we've got, again, helping out with the part numbers because there's a lot of different pieces in these. This kind of helps you identify what type of actuator it is. And we have cheat sheets. If you ever get stuck on what you need, reach out to your local rep. We have cheat sheets that allow us to go in and identify what's what on these. But you do need a specific tool. I got a part number up there on the screen. And the other thing I want to point out is there is a difference between the 2-way and the 3-way valve cartridges. The 3-ways are a little bit taller. So you'll see there's almost an added piece. I'll go back a slide. There's an added piece at the bottom that allows it to operate in that 3-way configuration. And then when you get to the actuator, this is what makes this valve series unique. We have lots and lots of different options for the way that you want to actuate these valves. So if you're looking at the VC series actuators, we make it in 3 different voltages for on-off. So we have 24 volts, 120 volt, 240 volt. But then we also have 24 volt floating. We have 0 to 10 volt or 4 to 20 milliamp, which is an external signal that you give to basically tell it where you want it to open and close to. And we can also do pulse width modulation. So those bottom 3 that I'm showing you there, the floating 0 to 10, the 4 to 20 milliamp, and the pulse width, those are all going to be controlled through some kind of an external control. So we offer our T775s, which is a modulating control that you can do a lot of different things with. But where I see these most commonly linked together is we have an outdoor reset modulating control. So what you'll do is you'll put in your 3-way valve, you'll use our T775 with an outdoor reset, and what will happen is you'll use a system sensor on the outlet that will fluctuate that valve to make sure that it's taking a blend to deliver the correct temperature through the outlet of it. But any control, if you're working with an existing control system, these valves can be retrofitted in as well. Now, when you're looking at these different types of actuators within the VC series, This is where the wiring is a little different from what most people are used to. We have two different series. We have a single pole, single throw. We also have a single pole, double throw. So pay attention when you're ordering the actuator to get the one that you're looking for, because they are going to wire up completely different. And if you look at a relay, this is from an electrical standpoint, this is pretty simplistic from an electrical layout. But when you wire these up, these are our single pole, single throw actuators. And I'm showing two different configurations here. One of them with no in switch, or I should say auxiliary switch, and one of them that does have an auxiliary switch. If you look in the little dashed box, that's the number of wires that have to tie to the thermostat. And I've got some better diagrams. I think they're better diagrams that I'll show you here just a minute. But if you're looking at, there's essentially with this series of actuator, the valve takes 3 wires to operate, but the thermostat only needs 2. So what that means is you're going to take your, and I'm showing the R and C contacts, so I'm only showing the low voltage options here, but you're going to take 24 volts and you're going to take it straight to the brown wire so that it has constant power at the actuator. You're also going to take 24 volts and take it up to the thermostat. It's going to land on R on the thermostat. On a standard thermostat, W is our contact relay for heat. So when that thermostat calls for heat, it's going to send 24 volts out across W, which is going to tie to the black wire on the actuator. And then your common all has to tie back together to create the circuit. So the way that works is the brown wire always has voltage on it. And then for that valve to open, what you're going to do is you're going to send 24 volts to black. And that's done through the thermostat. And then right below it, I still show the same actuator, but with an in switch or an auxiliary switch. So what you're going to do there is, as opposed to our previous series, which if you have an in switch, it's just 2 wires, this one actually gives you 3. So you're going to use common and normally open. So when that valve opens, it's going to close a set of contacts across common and normally open, which is the orange and gray that I've got starred there, which is going to tell the pump to operate, the boiler to run. And the reason we do that is it's basically a proving switch. And this is going to be standard for any of our valves that have in switches or auxiliary switches. We use it so that we don't turn the pumps and boilers on until the valve is all the way open. So some valves open quickly, some valves do not, but you don't want the boiler to fire if there's nowhere for the water to go. Because what will happen is without anywhere for the water to go, it's just going to short cycle, kick on and off over and over and over again. So with these, this is probably the most misunderstood piece of these valves. Still wires to the thermostat the same way. The only difference is the wiring at the valve itself. Now, we also do offer a single pole double throw valve in the VC series. So this one is a little bit more different. If you look again in that boxed area, the dashed boxed area, we're showing 3 wires that have to go up to the thermostat. Now, not all thermostats are going to be compatible with these series of valves on the single pole double throw. What you're going to have to do if you look at our series of valves, it's going to have the capabilities to either program it as what's called a Series 20 or as a radiant heating application. Because what you're going to do is, the way the wiring is going to work at the thermostat, you're going to have to take 24 volts up to the thermostat. And then the thermostat is going to have to send voltage out to open it and to close it. So you're going to have power out across W to black to open it. And then to close it, you're actually going to take the cooling relay and take it back down. So it's a little bit different on these. The auxiliary switch is still exactly the same, but I want to give some different visuals on how to wire up the valves. If you look at our standard zone valves, we make these with and without in switches. So if you look at the wiring on this, I've got a couple of different examples. If you're going to use a standard transformer, look there on the left-hand side. So R from the transformer is going to go up to R on the thermostat. It's going to come from W on the thermostat to the motor, and then the other leg of the motor is going to go back to common. It doesn't matter which one is which. And actually, now that I'm looking at this, I think we got it wired backwards there in this example, so apologize for that. But essentially what's going to happen is R goes to R, W goes to motor, and motor comes back to C on the transformer. That completes our circuit. The in switch is just used to turn either a pump or a boiler on. And then if you use one of our hydronic panels, very, very simplistic to wire up. And the other thing I've done is if I've shown how you wire it up to a power required thermostat, something like Wi-Fi where it's very high power draw. So I'm showing the common wire to the thermostat also. So R up to the thermostat, W to the thermostat, C to the thermostat. And then down at the bottom, we've actually color coded our hydronic panels so they match this series of zone valve. And the reasoning that is the V80 series is probably the most common zone valve that we sell in residential and light commercial applications. This is essentially how you hook it up. So we've tried to color code everything to make it as easy as possible. When we get into the VC series, I was telling you that it's very, very similar to our previous V80 and V40. Well, it continues this way with the wiring as well. So if you look at the wiring here, it's wired up the same way. So R goes to R in the thermostat, W would actually connect to black on the motor, and then you can tie your red back together. So I did want to show the difference if you're using our hydronic panel and you're not utilizing the in switch or the auxiliary switch. What you're going to do on the hydronic panel is actually jumper across 3 and 4, which is basically the second that that thermostat calls for heat, it's going to send a signal out to tell the boiler or the pump to come on. Now, these are the ones that I get asked about a lot when it comes to wiring. So the VC series, if you're using the single pole, single throw, the wiring is actually not that complicated. So if you come across, it's going to wire up pretty standard into our, and I'm going to actually, let me back up and start with the transformer. So you're going to have transformer R and C. You're going to go up to R on the thermostat, W to black, and then your brown gets that constant power, and then your C comes back to the transformer. Looking at it from our hydronic panel, we're going to take the same wiring to the thermostat. So in this example, we're using a Wi-Fi thermostat, so we're using 3 wires. The zone valve down at the bottom, that VC series, is going to wire up pretty straightforward. It's just about making sure you connect the right colored wires to the right terminals. So the motor is going to be black and brown. And then we've got, black and blue is going to connect at the bottom. But then I show how you bring the R across there on the outside. Now, what I've had a lot of contractors do as well is, if you look, I'm kind of showing this off to the side. This is the one that doesn't technically connect through the board. You can still bring that thermostat wire through the cover on the board, so it kind of hides it. I just want to bring that off because that's the one that's kind of different, is that one extra wire that has to connect to the valve. Now, going into this one, this is that single pole double throw. If you're using this style actuator, as I had mentioned, you have to make sure that you've got a thermostat that's capable of driving this style of valve. Not every thermostat is going to be able to do this. So if you ever have any doubt, we make lots of them that can do this, but just reach out to us. Let us know if you've got any questions at all. So the way this one's going to operate, and I'm going to talk about this one for a minute because it is a little bit confusing. So what's going to happen is, if you look at the top of the valve, I've got the wiring across R, W, and C right to where it goes on the thermostat. That's our standard wiring. R is power into the thermostat, W is our heat relay, and then blue is just our constant for powering the thermostat. Where this varies from all the other series, you have to take a leg off of Y, which is going to be your cooling relay in most applications. So what the thermostat's going to do is, when there's a call for heat, it's going to send 24 volts out across W. So that goes down to the valve. But since these are not spring return valves, you're going to have the thermostat send 24 volts out across, in this case, Y, which is our cooling relay, so that it powers the valve back closed. So I've got an example here I think it makes more sense personally on the hydronic panel that I'm showing on the right-hand side. So the wiring is still fairly straightforward as far as the thermostat. The only difference is you need one extra wire at the thermostat that's going to connect to the brown wire on the actuator, which is going to power it closed. So when the thermostat calls for heat, it sends 24 volts out across W. When the thermostat call for heat ends, it's going to send 24 volts out across Y. So there's always 24 volts going to the actuator. It just has to determine if it's going to be to close it or to open it. So our thermostats, if it's one of our Programmable, you're gonna have two different options depending on the series. If you program it as a radiant heating thermostat, it'll operate just fine. Or if you tell it with some of our previous generations, if you go into the programming and lock it in as a what's called Series 20, that's going to do the same thing. It's going to kick the algorithms inside of it to operate in this style of an operation.
Thanks so much, Chris. We appreciate you walking us through that overview of our hydronic zone valves and fan coils. If you're interested in finding out more information on the products that Chris covered today during our training, make sure that you visit our Resideo Pro website. We are adding new features and new products regarding all of our solutions every day, so please be sure to refer back to that Resideo Pro website for more information. We are going to transition to answering some common questions that our sales team hears quite frequently about our hydronic products. We're going to bring in Mike Ortiz, who is part of our Resideo Water Inside Sales Team, to join Chris in answering these common questions. And then as a reminder, if you do have any questions on anything that was reviewed today in our presentation, I encourage you to take a few moments and enter that information into that Q&A feature in your Zoom controls, and we will do our best to answer your questions in the time that we have remaining.
Good afternoon. Thank you for that, Chris. So we're looking at a few more of the more common things that come up when we're talking about our valving. And we're going to start off here with, can I use the zone valves in potable water application? This time, go ahead.
Oh, go ahead, Mike.
Well, at this time, we do not have a potable water application for our valves. They're primarily for closed loop hydronic systems. And as Chris mentioned earlier, those are systems that are oxygen, have tubing with oxygen barriers to keep the minimum corrosion off of the system and off the components. Second question is, can I use an existing modulating controller with the VC valves? You can go ahead and take that one, Chris.
Yeah, sure. So this comes up a lot. So we get a lot of people that are replacing third-party valves, and I won't name any names on those brands, but there's already existing controllers, and a lot of times there's no reason to change the control that exists. It's already been programmed, it's already been set, so you really don't want to mess with it. But if the valve fails and you want to use ours, because we believe ours are superior, yes, you can absolutely take it out, pipe ours in, and connect it to the existing control. So just make sure you choose the correct valve. As I had mentioned in the VC series valves, we have 3 different types of modulations. So we have floating, we have pulse width modulation, and then we also have a 0 to 10 or 4 to 20. So as long as you match that up to the control that's there for the signal that it's sending, yeah, you can absolutely use our valve with a different type of controller.
Great. Which thermostats can I use with your zone valves?
So Mike, I love this question, and I get it all the time. Short answer, any of them. It's gonna, with the asterisk of it depends. The one thing I do want to kind of touch on with that type of a question is, if you're looking at just doing heat only, I mean, we make our Pro 1000 series thermostat that works just fine. It's a battery operated, simple 2-wire thermostat that works just fine. But the one thing I will say is, we're seeing more and more people start to migrate over to Wi-Fi thermostats, connected solutions. So we have a RedLink offering, we have a Wi-Fi offering, we even have a Z-Wave connected offering. So there's lots of different options on every single one of our valves, or I'm sorry, every single one of our thermostats. It has the capabilities of operating in a radiant heating application. So the only asterisk I'll put on that is if you need to run a floor sensor. So let's say instead of measuring the air temperature, or I should say ambient temperature, if you want to measure the floor temp, we do have a T6 hydronic. But in short, pretty much all of our thermostats work with our valves. The one asterisk, as I'll bring up again, is that kind of unique VC series single pole double throw. That one's a little different. That one you have to use a programmable thermostat. And ours have the capabilities of operating in that function. I don't know about other brands.
Great. So lastly, do I need to remove the zone valve to service it? I'll take this one, Chris. You know, we offer a lot of different application parts, and as Chris was saying, you know, just depending on what you're looking at, as long as we're dealing with anything on the electrical side, whether it be the motor or the end switch, we don't need to remove the valve from the system. If we get into the wetted ways, then at that point, actually we can access the valve from the top and the top plate just by isolating it from the system. So it doesn't actually have to be removed. It can stay in place and can be serviced.
And I'm going to make one last call for questions. We've had a couple of more administrative questions come in. If anyone has questions on anything that either Chris or Mike have touched on, go ahead and let us know here, and we can take another few moments here to answer your questions. Chris, is there anything else that you feel like our attendees should know about our Resideo water portfolio at this time?
At this time, the one thing that I will highlight is we offer pretty much the entire mechanical room solution. So we OEM a lot of parts for boilers. We don't do tubing, manifolds, baseboards. So we don't do the actual heat emitters, but we try to package everything so that we can deliver a solution for everything in the mechanical room. So we've got circulators, we've got air eliminators, expansion tanks, fill valves, backflows, valves, as we're talking about today. So we've got a lot of different solutions and hydronic offerings that can fulfill just about all of your needs.
Great, thanks so much. And thanks so much, Mike, for jumping in and answering those questions. And a big thank you to Chris for providing us with that overview of our hydronic zone valves and fan coils. Just a quick note, we are going to feature one water training each month. So go ahead and look forward to that information from us going forward as we make sure to get you all the information about our water portfolio going forward. And then next week on Tuesday at 2 p.m. Central Standard Time in our next edition of the Resideo Customer Webinar Series, we're going to start talking about steam humidification and controls as we get ready for heating season. So please go ahead and register for that training, share that information with your teammates, and we do look forward to having you join us on that next upcoming training session. If you'd like more information about our webinar series, go ahead and visit resideo.com/webinars for more information on our upcoming sessions. The October list is up on the website and is listed underneath either the HVAC or the plumbing tabs for your reference. And then one quick reminder to our contractors who maybe did not include your information for NATE credit on your registration form and you would like to receive credit for today's session, go ahead and send an email with your first name, your last name, your NATE ID number to homes.university@resideo.com within 1 week of today's live webinar, and we will go ahead and get you credit for attending this live session. And then there's two final things to note once we end our training session today. You are going to be prompted to complete a survey regarding today's webinar session. Please take a few moments to provide us with your feedback on the training that Chris provided all of us today. We are looking forward to offering these sessions in the future, and your feedback helps us as we prepare for those upcoming sessions. And we do want to hear your feedback on today's session. Finally, you are going to receive an email from us in just a few days that includes some follow-up information on our hydronic products that we covered today, as well as a link to the website for more information on our future webinars as well. Thank you all for joining us for today's Resideo webinar session. Make sure to join us next Tuesday at 2 p.m. Central Standard Time for our next training on steam humidification and controls. Have a great day.